Number one on the practice midterm, we need to add these two fractions up. However, we cannot do that yet because we do not have a like fraction. So we need to come up with a common denominator. Now, there's two methods that we can use. We can use the factors of each number, which is 6 times 1, 6 times 2, 6 times 3, and we look for a common factor, the lowest common factor. And this is 9 times 1, 9 times 2. We can see it's 18. Or if it was a much larger number, you could break it up in factors, prime numbers, such as 2 times 3, and this would be 3 times 3, because we know 2 times 3 is 6, and 3 times 3 is 9. So that's the first part. Now, the second part is to say, okay, well, I can see that we have a 2, we have a 3, but we have to evaluate how many times each number occurs. Now, 2 occurs only one time. Now, the 3 occurs twice. Now, we got to look at the 3 per line. Now, in this particular line, the most amount of times it occurs is 2. So that's why we take it to the second power. Then we just multiply this out. So 2 times, and we know 3 times 3 is 9, so 2 times 9 is simply 18. So there you go. There's just another way of figuring it out. These numbers were small enough that we didn't have to use this approach, but when the numbers are very high, which we're going to show you how to work through in number 3, I would recommend using that approach. So once we have our common denominator, we're just going to come up with equivalent fractions so we can add up these like fractions. So we need to multiply it by a form of 1. And how we do that, how we get that form of 1 is we just take 18 divided by 9, which is 2. So 2 times 9 equals 18. So 2 times 1 is simply 2. And then 18 divided by 6 is 3. So 3 times 6 is 18. So 3 times 5 is 15. So we can go ahead and write this now as one fraction with the same denominator, add it up, and we have 17 over 18, and we cannot reduce that down any further, and that is our final answer. All right, let's work on number 2. Okay, now we're going to take these two fractions and we're going to multiply them. But it's always recommended to go ahead and try and break these down in factors before to do it, so we can reduce before we multiply. So this one can be expressed as 3 times 4. This one is 7 times 3. This one would either be 8 times 5, 4 times 10. It doesn't matter. And then this one is 7 times 5. Now, we can see this number here can be broken down even further as 2 times 2. So now they're all primes. Now I'm going to go ahead and write those out. So 12 is expressed as 3 times 2 times 2, which 4 times 3 equals 12. And then 21 is expressed as 3 times 7. So there you go, it's all prime numbers. And a 35 is written as 7 times 5. And 40 we have as 2 times 2, which is 4 times. And the 10, I'm going to break it down even further as 2 times 5. I should have wrote that as 2 times 5. And that represents 10. Okay, now I'm going to go through and see what can reduce down. So I don't have any 3's on the bottom. I do have a 2 and a 2 here. I have a 2 and a 2 here. They reduce down to 1. Here's a 7 and a 7 here. And it looks like that's the only thing I can reduce down further. So our final answer on my numerator is 3 times 3 is 9. And then we have 5 times 5 times 2, which is 25 times 2, which is 50. So our final answer is 9 over 50. So the strategy again is to break it down into prime numbers. So that way we can get anything in the numerator and the denominator to reduce down to 1, and then we multiply it out. Okay, let's move on to number 3. Okay, here's our other strategy to use. If we had fractions and they all had not the common denominator, and sometimes it's hard to come up with a common denominator when you have more than 2 fractions. So this is a strategy that you can use. So we're going to break them all down in prime numbers, and then we're going to collect them to come up with our lowest common multiple. Now, 8 can be expressed as 4 times 2, or I'm just going to write it as 2 times 2 times 2, all prime numbers, which equals 8. 10, we'll express it as 2 times 5, that's prime numbers. And then 30 will be 5 times 6, and I'm going to write 6 as 3 times 2, because that is equivalent to 6. So now I'm going to go ahead and look and say, okay, well, I know I have a 2, a 5, and there's a 3. I'm going to collect, and I see, okay, 2 occurred. Now, this first line, the most amount of times it occurred was 3. The second line, it only occurred once, and the third line, it only occurred once. So the most amount of times it occurred was 3. I'm going to multiply that by, now I have a 3, that only occurred one time, and then we have a 5, that only occurred one time. So now we take 8 times 3 times 5, and it looks like we end up with a value of 120. So there's our answer. Okay, now number 4 is order of operations. Remember, please excuse my dear Aunt Sally. Multiplication and division must occur left to right. It doesn't matter if you divide or multiply first, as long as you do those before you add or subtract left to right. So let's start evaluating. We're going to pick 2 numbers. We can go with the first 2 numbers because we don't have anything in parentheses and we don't have anything raised to an exponent. So we don't have to worry about that. So if we take 24 divided by 8, we'll end up with 3. So the rest of it, I'm just going to write out because I didn't do anything with it. All right, now I'm going to take a look and see what other 2 numbers I can go ahead and deal with. Now, again, we cannot add before we multiply. So I must skip over and grab these 2 numbers because I have to multiply first. So I'm just going to write my 3 because I didn't do anything with it. And 4 times 2 is 8 minus 6. Now, the only thing I have left is adding and subtracting, so I can go ahead and just do that from left to right. And if I take 3 plus 8 minus 6, if I enter that correctly, I should end up with a value of 5. Okay, now in this next problem, we have 6a to the 3rd power times 8 times a to the 2nd power, b to the negative 3 power. Okay, so for myself, I always like to deal with my numbers first. I'm just going to go ahead and multiply those 2 numbers out. And what I do, I end up with 48. Now, the rule states whenever you have an same base with a power, when it's being multiplied, you're just going to go ahead and take those 2 powers and add them up. So since these are the same base, my answer would be x to the 7th power. So let's apply that rule over here. So if we have a cubed and a squared, that simply is add them up, and we have a to the 5th power. Now b to the negative 3, there is nothing to combine that with, so I'm just going to write it. Now we know that we usually in our test, I will not allow negative exponents in your answer. So just remember, this is really over 1, so that way we understand where to shift that negative number. So the final answer here would be 48, a to the 5th power. We're doing nothing with that, but we're moving b to the 3rd power down in our denominator. And this would be our final answer. This now is expressed without any negative exponents. Okay, number 6. Now this is the same thing as if we have x to the 6th power raised to a power, we're supposed to take those 2 powers and multiply them. So this answer here would be x raised to the 12th power. Okay, so let's go over here and apply that rule. So this would be 2 to the negative 2, x, and then 4 times negative 2, which is a negative 8. And this one is y is negative 3 times negative 2, which gives us a positive 6. And remember, this is really to the 1st power. Once eliminated, it's understood to be known 1. All right, now I'm going to rewrite this, making sure that all the negative exponents are expressed on the bottom. So let me just go ahead and draw a line so you understand this is expressed over 1. we're going to move this one down and we're going to move this one down, but this will remain up in the numerator. So to rewrite that, I would rewrite it as y stays up in the numerator, no changes there, but however, we're going to put 2 squared down here and also x to the 8th power, which our final answer would be y to the 6th power and then 4x to the 8th power. And that's our final answer expressed without negative exponents. Okay, for this next problem, now the rule states whenever we have the same base and we're dividing, all we do is subtract those exponents. So 3 minus 1 would be x squared. All right, so now let's apply that. So you can see we have an x cubed and an x to the 8th power. We have 2 y's. We have y to the 5th power and y squared. Okay, now you can see that 12 divided by 9 does not divide evenly, so we have to reduce that out. So I'm going to start with that. So I'm going to use 3 times 4, and then we have 3 times 3 to represent 9. And you can see the 3's reduced down to a 1, which leaves us with our 4/3. Now, to deal with our x's, I'm going to go ahead, and we know that when we solve for x cubed divided by x to the 8th power, that simply becomes x to the negative 5. Now, remember, that's like over 1, okay? So that's why I'm going to write it up here on the top, which is to negative 5. And then when we have 5, so remember, 3 minus 8 will give us negative 5. And then over here we have 5 minus 2, which the y will give us 3. Now, we have a negative exponent. That means that has to move down here. So our final answer will be 4y cubed over 3x to the 5th power. And that's our final answer there. All right, now we have a radical. So the way to think of this radical symbol, you could say, okay, we'll think of it as a parenthesis. I'll look inside the parenthesis and see if there's anything that can be done. I can't reduce it down to whole numbers, so I can't use that strategy. So the next thing I can do is break it up into a numerator and a denominator. And then I'm going to plug that into the calculator, the cube root of 8, to see if I get a whole number, to see if that works. And if you plug that in, you should get the whole number 2 as your final answer. And then I'm going to use the same thing with the 125, and you should get an answer of 5. That means 2 cubed is 8, and 5 cubed is equal to 125. So this is our final answer for number 8.